Yeah, comes on everyone. Let's start off. Hope everyone has gone through the notes. Great. So this was the last thing that we did. Great. Let's see one more question. These models which I'm teaching you now, I kept them for today because last class is almost at the end and I don't want you guys to miss it out. So this is an important one. You can put a star also for this. We have two resistors in parallel, R1 and R2. Let's say R1 is 10.0 plus or minus 0.1 ohm. R2 is 5.0 plus or minus 0.1. And we know if resistors are in parallel, 1 by R equivalent is 1 by R1 plus 1 by R2. Find percentage error in R equivalent. How will we do this? Try. Now this thing is not looking like addition or subtraction. This thing doesn't obey power rule. This is something else. Listen, I'll show you one. Now these kind of things, right? This is the thing we use. Differentiate on both sides. So 1 by R ka differential is R power minus 1. So that is minus 1 by R square into dr equivalent chain rule. This is minus 1 by R1 square dr1 minus 1 by R2 square and dr2. So dr equivalent by R equivalent will be R equivalent dr1 by R1 square dr2 by R2 square. So what is 1 by R equivalent here? So 1 by R equivalent is 1 by 10 plus 1 by 5. That is 3 by 10. So R equivalent is 10 by 3. dr1 is 0.1 by 10 square. 0.1 by 5 square. You want percentage error. So just multiply with 100. 10 will go inside. So this is 1 by 3, 1 by 100 plus 1 by 25 into 100. That would be 1 plus 4, 5 by 3 percentage. This is 1.66 percentage, but we have only one decimal there. We have to round it off to 1.7%. Check. This is how you do. You have to differentiate. There's no way out. We can't use addition subtraction stuff. We can't use the power rule. So you have two terms. First of all, you are adding them, but they're in the inverted denominator. So differentiation is the way. This is the technique they gave it in NCERT. We will stick to it. And generally, it is works. But only problem is this thing works only for very small errors. Why? The moment you say differentiation dr, what do you mean by dr? Very, very small change, isn't it? You can't have 10-15% errors. So 1 to 2 to 3% errors is acceptable. Anything more than that, this thing will start going. Last time we saw, right? 1%, 10%, we saw the errors we started getting. Things getting messed up. So small errors, everything is fine. Errors are becoming big, then the problem starts. Clear with this? Let me show you one more like this. Turn the page. 1 by u plus 1 by v is 1 by f. U is the image distance. This is the mirror formula. This is an I wrote reverse object distance. We will learn this in optics. F is the focal length. The U is 10 plus or minus 0.1 centimeter. V is 20 plus or minus 0.1 centimeter. Find focal length. Means I'm asking F plus or minus delta F. So this and the previous one, mathematically, they're the same formulas. Just the formula is different. It's for mirror, that is for resistance. Max doesn't care. Idea is the same. Give it a try. Like these models were quite important. So I wanted to do it when you're a little fresh. Let's see. Got the answer? No, I don't want error. I want F ka value. Means you should tell me something like 12 centimeter plus or minus 0.2 centimeter, something of that sort. So let's differentiate this. You'll get minus du by u square, minus dv by v square, minus df by f square. So df will be f square, du by u square, dv by v square. And what is 1 by f? 1 by u plus 1 by 20. This is 3 by 20. So df will be 400 by 9 0.1 by 10 square, 0.1 by 20 square. This would be 0.1 by 9. That would be 4 plus 1. That's 0.5 by 9. That would be how much is that? 0.55. 5 is there. 5 ka before there's an odd number, so we have to round it off to increase this thing 0.6. Isn't it? 0.55. When you have to round off to one decimal because there's only one decimal here. And then yeah, done. So focal length would be 20 by 3. So that is 6.66 centimeter. We need to round off that also. F is 20 by 3. So this would be 6.7 centimeters. 6.7 centimeters plus or minus 0.6 centimeters.
Sir,
Are.
so that will be 0.055, no?
Yeah, I'm just testing you guys. Devansh has proved himself. So this thing will round off to 0.6, no, 0.1. Now we need to round off to one digit here. Shit, this is coming bad actually. We need to round it off to 1 SF. So we need to round off to 1 SF because these zeros are not counted anyway. So 5 ka before 5 to 0.1. Yeah. Clear? That will go 5, 5, 5, 5 will keep on going. I should have given like 0.010 to be more precise. Like I said, the measurement itself is bad. It should have been 0.10. Then your answer would have been 0.06. That would have been more precise. We can do that. Kar lete hai na? This is what I was saying in the beginning. If your measurements are not proper, you'll start getting big errors. This is better. That means I can make this also 6.67 then. Did you see? By putting one more decimal, it starts looking a little better. More decent error you're getting. Clear with this? Next one. Any doubts on this? I hope you're getting it. So if you get something like this, you just differentiate. Let's say we have something like z minus 20 by z minus 5. So z is given as 10 plus or minus 0.01 centimeter. Find error in A. I'm not sure about the values properly, but the process is more important. Find percentage error in A. Now, this is another type of questions. Like the functions don't look like any standard ones. Z minus 20 by Z minus 5. This whole thing is one term. Find the error in A. 0.5. Let's see. Again, like I said, right, if it is not addition subtraction, if it is not power rule, you don't have an option. The third technique is differentiation. Differentiate on both sides. This will be dA, this will be dz minus 20 by, if you differentiate this guy, it will be minus 1 by z minus 5 whole square into dz. Chain rule, z minus 5 whole power minus 1. So this is dz plus 20 dz by z minus 5 whole square. So dz is 0.10 plus 20.10 by z minus 5. 10 minus 5, 5 square, that's 25. We want percent error, right? So you want A ka value also. What is A? A is 10 minus 20 by 10 minus 5. That would be 25 before 6. So A ka value is actually 6 plus or minus. How much is this? 0.10 plus 5s are 4s are 0.40 by 5. That would be 0.18. Am I right? 0.18. So, yep. So percent error in A would be 0.18 by 6 into 100. That would be 3%. Check. Or did I go up somewhere? There. So if you give me some property like this is the only technique that we know. So 3 techniques. Addition subtraction is easy. Power rule, differentiation. All clear with this? Now after this, we also have something called one-year calculation screw gauss, but that we will do once the portion gets over. Because there's no point in learning that now, you'll forget anyway. And that is important for advanced especially. So we will be doing again in the end after the portion gets over. We will do errors again, and we will do instruments again. Instruments and errors together again. Right, so with this, we are done with UDE. I have sent you the sheets also. Hope you have done it. So do finish it off. We can discuss those doubts also on Thursday, along with the paper. So if you just finish off those sheets, I think that will be sufficient. Most of the things will be taken care by that. And this week, test schedule also sent you. This week exam on Saturday will be units and dimensions error. That's for the next week. So that is one. ठीक है. So there are just 2 things for that thing exam. Whenever you hear the word modulus, I couldn't change this in the paper. So you will hear these words in the paper. Rigidity modulus. Symbol will look something like this. So these things have units same as pressure. So keep this in mind when you're writing the exam. And we know F is equal to 6 pi r eta V. This eta is coefficient of viscosity. You will need these 2 things. There are 2 questions based on this part of it. So you will need them. So eta is proportional to force by r into v. This too we did in the class also. This is mlt minus 2 by L into LT minus 1. There. Just keep this to mind when in the exam. Young's modulus, rigidity modulus, when you hear these words, they have the same units as pressure. Pressure is force by area. And you'll hear the word coefficient of viscosity. I forgot to add this while making that question. I realized it after putting it. So after the exam, don't come and say, sir, we need bonus marks. I'll punch you. I already told you before only. Clear with this? Great.
So can you show that slide once again?
I'll keep it there. It'll be there in the last page only.
Okay.
It'll be there in the notes last page. Mein. With that, we're done with UD. Next thing, Newton's laws of motion. Quite an important chapter. If your laws of motion is messed up, then you'll mess up friction, then you'll mess up circular, then you'll mess up work power energy, you'll mess up next 10 chapters. That means you'll mess up your physics. Yeah. So this is your base chapter. So you can simply call it, I call it mother of mechanics. Surya, why are you eating the book? Don't eat the book. You can eat something else. So I know there is a technique called diffusion technique. Like when you want to gain knowledge fast, you eat the book directly. It gets digested into your DNA. I know, but you can do those techniques in IIT. IIT, my friends used to do such kind of nonsense shit. I told you about that guy, right, who used to sleep in the library. Told you, no? So whenever you go to the library, this guy is there. He used to take a pile of books, like 6, 7 books, and happily used to sleep there, putting the head on the top, like a pillow. So I called him, Are, come na, we will go out. Karke. Something I told him to come. He said, No, I'm busy studying in the library. I went to see what he's studying. He's sleeping happily in the 4th floor, completely air conditioned. I said, What the hell are you doing? He said, This is a diffusion technique. I said, What? He said, Knowledge always flows from high concentration to low concentration. The books here contains a lot of knowledge. My head here has zero knowledge. So by sleeping on the book, by using the diffusion technique, the knowledge will eventually try to come into the head automatically. Ready? So that is what happens when you study a lot and go to IIT. Your jokes also will be like that only, science jokes. And that's part, what only you and I will understand. If you try to do this joke in front of your relatives or cousins, they will feel like, what shit are you talking? So to understand this level of jokes, you need to have that level of people also. Anyways, when I think about diffusion, I remember that idiot only. Next thing, laws of motion, quite an important chapter. In this, primarily there are 2 parts. The first one is constraint motion. Second is free body diagrams. These two, you'll be able to handle the chapter. It's not difficult chapter, but one thing that I noticed, right, normally when people teach this topic, right, they don't give enough time to do the basics properly. They just rush in and everything comes in a problem. That is when it starts getting messy. If you see that how we did kinematics also, we did in a pretty orderly form. 1D ke baad, then we said 2D is nothing but 2 1Ds. So every time we try to connect all the things that we learned before. That way, right, you will understand better and you will think, like I keep saying this, don't think everything is new. Whenever you learn something, maybe there is 60-70% old and 30-40% new. When you keep that in mind, you won't find it overwhelming. So let's see, the first part that we'll do in this is constraint motion. So what is constraint motion? If the motion of a body depends on motion of other bodies, the motion is said to be constrained. Let me take an example. Let's say if you have a body A which is going with 5 meter per second, and somewhere here we have a body B here. If I ask you what is the speed of B, here VB can be anything. A and B have no relation to each other. A can do whatever it wants, B can do whatever it wants. It's like asking a bird flying in the sky and you walking on the road, what's the relation between them? Nothing. But same thing, when you take your dog for a walk in the evening, is there a relation between you and your dog speed? When you're taking it with that leash, right? If the dog is running away and if you're not strong enough, the dog will drag you along with it. Getting it? So you both are constrained. If you're not ready to move, the dog can't do anything. If the dog doesn't want to come, you have to forcefully pull it. You both are constrained to move. So here, motion of A and B are independent of each other. So we say the motion is not constrained. But the same thing, suppose if I do like this, if I take B here, and let's say you connect this with a thin rod, a rod basically. Now, if you tell me A is going with 2 meter per second, the B doesn't have a choice. Since the rod is rigid, assuming the rod doesn't break, VA has to be equal to VB. Meaning now they're related, A and B will go together. So motion of A and B is constrained. So to put it in more simple words, now think of like this. Let's say we have two people, A and B. Okay, I have 10 apples. So listen carefully. I have 10 apples. The condition is I have to give all the 10 apples. Okay? I have to give all the 10 apples. The moment I give 3 apples to A, does B have a choice? B has to take 7, isn't it? So even though the question looks like I'm dividing apples between two people, in reality, there's only one choice, isn't it? It looks like you're choosing for two people, A and B, but in reality, there's only one choice. The moment you decide for A, B ka value is fixed. The moment you decide for B, A ka value is fixed. Does that make sense? It's like sometimes, you want to go out somewhere and you ask your mom and your mom is not at all happy about it. Then mom gives you a choice. You want to go? Go. Right? You don't want to go? Don't go. It looks like there are two choices. But there's only one answer. You go, I will see. You're getting it? So that is what I mean. It's a constraint. When your mom says you go, I will see, or you say you don't go, like there is an option. You decide to go, what will happen. So even though it looks like two choices, in reality, there is only one choice there. Getting it? It is constrained. So same way here, it looks like you're choosing for two people. There's only one choice. Another example like that, think about it like this. In your refrigerator, there are 3 chocolates. Your sister is there with you. Your sister ate 2 chocolates. How many chocolates you have? Technically, she'll eat everything, but let's say she felt bad for you and left one. So you're getting it. You don't have a choice. But imagine you and your sister go for unlimited buffet. She eats 10 cakes there. Does it matter to you? Now it becomes an independent choice. You can eat how much ever you want. She can eat how much ever she wants. Now there's no, they're not related to each other. They're unconstrained. Hope you're getting a point. So something similar happens in motion. Now there are 3 ways we can solve problems in this. There are 3 methods. Method 1 and method 2 are little standard. Method 3 is something which I made up by mixing up 1 and 2. So method 1, I don't like it much, but we will do that because we need it. The idea is important. So let's see the 3 methods. So again, constraints, there are 2 types. We have string constraints and rigid body constraints. So first we will deal with the string constraints. So there are 2 kind of constraints, string constraints and rigid body constraints. And there are 3 methods. Getting it? So we will see both. The first thing is the string constraints. This is related to strings. So what is an ideal string? So before jumping in directly, we need to define an ideal string. So in our study, we always take ideal strings until unless something is mentioned about it. So in ideal string, these are inextensible, meaning they don't stretch. Non-dissipative, meaning they do not waste any energy. And massless. So we'll assume all the strings that we take do not have any mass, even if they have negligible mass. So method 1, the idea is straightforward. In method 1, the main concept is length of the string is constant. So listen, the best way to do is with an example, you'll understand faster. We will take a simple case. So we have a pulley here, we have a block A here, we have a block B here. So first thing, let the length of the string be x on the left hand side. So x is the length of the string from A to the pulley, y is the length of the string from B to the pulley. Now you tell me, whenever A goes up and down, what will change? X will change. Whenever B goes up and down, what will change? Y will change. Make sense? So here x plus y is L, which is the length of the string. Differentiate on both sides. So this will be dx by dt plus dy by dt. This is dl by dt. But this term is 0 since length of the string is constant. Because no matter how much A and B moves, length cannot change. So what is dx by dt? Velocity of A. Because when x moves, when A moves, x changes. What is dy by dt? Velocity of B equal to 0. So we got velocity of A is minus of velocity of B bar. So basically what it is telling you is A and B will go with same speed, but in the opposite directions. So here negative indicates A and B are moving in opposite direction. This problem is kind of obvious because obvious, right? If A goes up by 2 meters, shouldn't B go down by 2 meters? Since the length of the string is constant. So this thing kind of looks obvious, but this is the process. Let's see what happens if we make it a little more complex. Have a look at this. Did you get the idea what we did? So method 1 is completely based on one concept that the length of the string cannot change no matter how much the blocks move. Let me take you one more example. Things will make more clear. Can I turn the page? Pratik, Arya, Arnav, can I go ahead? Let's see one more example. Let me take more complex one. Let's say this is A. This is B and this is C. Now here the problem we can see, 3 blocks are there. So let this be X. So whenever A goes up and down, X will change. Let this be Y. This also is Y. So whenever B goes up and down, 2 strings will change. Make sense? And this is Z. The total length of the string will be X plus 2Y plus Z is equal to L. Differentiate on both sides. This would be dx by dt. This would be 2 times dy by dt. This would be dz by dt. This side is 0. So this is nothing but velocity of A plus 2 times velocity of B plus velocity of C. This is the relation between the velocities. Now let me give you some numbers so you'll understand better how this works. Let's say A is going up with 2 meter per second. And let's say B is going down with 3 meter per second. And someone wants to find PC. Look at this formula. We'll keep the convention simple. Up positive, down negative. You can take down positive, up negative, doesn't matter, but keep one direction positive. So A is going up. So from this thing, it is plus 2. B is going down, so minus 3. C, I don't know. I'll just keep it as VC. So this will be minus 4 plus VC bar equal to 0. I got VC is equal to plus 4 meter per second. Plus indicates it is going up. Is this making sense? This is the constraint relation between ABC, meaning ABC ka velocity should always follow this condition. So if you give me two velocities, I can find the third one. Now, this problem is not as obvious as this problem, isn't it? This thing was obvious, na, first example. Second one is not so obvious. Have a look at this. So the main idea here is you need to see whenever the blocks move, how the length of the strings change, and then put it down. Have a look at this. Let me ask you one question like this. But I'll show you a technique. Method 2 gives you answers much faster than this and more convenient. So method 1 we will rarely use. Method 1 we will not actually use on anywhere. But I just want you to know the idea that the length of the string is constant. All clear with this? Show you a question. I'll give you a question. Now you guys try. You're getting how is that string? The string goes to D, goes up and comes back to the same pulley again. I hope you're getting how it is connected. A is going with 2 meter per second. B is coming down with 3 meter per second. C is going up with 1 meter per second. Find VD. Let's get this. Let me show you. See. Let this be X. So when A goes up and down, only the left side ka thing will get messed up. When B goes up and down, the two strings will change. When C goes up and down, two strings will change. I'll call it Z. When D goes up and down, I'll call it W, W, and W. Three W's will change. Do you agree? Just think like that. When the pulley goes up, three strings are changing at the same time, isn't it? So when the pulley goes up, meaning just सोचो ऐसा, अगर पुली इतना तक नीचे पुल कर लिया, this three strings have stretched, isn't it? So three strings are changing. So X plus 2Y plus 2Z plus 3W is 0. Differentiate. So keep it simple, like assume all are going up or all are going down. So differentiate. So this will be VA. This will be 2 times VB plus 2 times VC plus 3 times BD is equal to 0. A is going up, so plus 2. B is going down, minus 3. C is going up to 1, and this is 3 times VD. How much is this? 2 to 4, 4 minus 6. So VD will be 2 by 3 meters per second. I'm getting a positive sign, which is going up. Easy? Any doubts on this, everyone? Clear na, Abhinav, Daksha, Niharika, got this? Surya, Vignajit? Vignajit, adjust your camera a bit. I can't see your face, right? Next one. This method looks good, but it starts messing up pretty big when you have multiple strings or when things are at angles like this. So this is A, this is B, this is angle theta. A is going with U downward. VB is this way. Assume, block B slides on the floor. It does not lift off. And did you observe one thing in all these questions? I don't care about the masses. Constraint motion doesn't care about the masses. It gives you the relation between the speeds. Based on the masses, speeds will change, but the relations will not change. Block B slides horizontally with VB. Find VB. So A is being pulled down. So B is going down at an angle theta at this instant. Let's get this. That is a trap, Vihan. People do get confused here. Is it U cos theta or U y cos theta? I'll show you. Get this thing. The method 2 will keep your life easy. Put it on. I just wanted to show you method 1 and I wanted to show you why it is a little complex. Idea is important. Nay, it is not. You're wrong, Purvaja. Surya, Vihan, all three of you are wrong. Try. Just try to solve it normally. I know most of you feel like you know the answer, but that is wrong. So solve. Your feelings are 99% of the time are wrong. As you gain more and more experience, your feelings will improve a bit. It's actually instinct. Itna kyun? After teaching for 15, 16 years, even when I feel for an answer, 50% of the time I'm also wrong. I don't trust my feelings in physics. To solve. Remember the concept, length of the string is concept. Give it a try. Take a minute. No, just you two completely got something else only. I asked to draw a dog. These people drawed a donkey. You drawed a Godzilla. The answer में इतना difference है. नहीं रे अंश. You also got a Godzilla. Tan function is a Godzilla. Why did you assume only vertical is constrained? What are you talking? Vertical क्या constrained है? Try. I'll show you. Use length of the string is constant, huh? Just give it a try. I'll be back in a minute. Let's see. Let this length be x. Let this height be h. H is constant. That is the height of the pulley from the base. Now, if you look at the length of the string, let this be y. This will be root over x square plus h square. Agreed? Pythagoras theorem. Now, few things here. When this guy is going to the right, Vv is minus dx by dt. Since x is decreasing, we have seen this. Whenever x is decreasing, dx is negative. Technically, we should take this. So x is decreasing, it is minus dx by dt. And second thing, we can see from there cos theta is adjacent side x by root over x square plus h square. Great. Now, what is length of the string? Length of the string is y plus root over x square plus h square. Differentiate on both sides. You will clearly see why this method becomes length is 0, and this is dy by dt. This is 1 by 2 root x square plus h square, chain rule. Differentiate inside 2x dx by dt. This becomes velocity of A plus this becomes x by root x square plus h square is cos theta, and dx by dt is minus vb. So from here we get vb is equal to va by cos theta, which is u by cos theta. That's your answer. Now, there is a constraint method also. We say velocity along the string must be same. We will see that later on. We will use that logic that comes in rigid body constraint. I think we will do there. But for now, let's stick to this thing. Because I have seen most people write, they read u cos theta. Some people write u by cos theta, they get confused. Forget about it. Let's stick to the method. It will give you the answer. Just put down that. Clear with this thing? So this is method 2, method 1. So let's see method 2. Method 2 is the best one. Saves you time, gives you the answer, but you lose understanding. Turn in the page. Method 2, people call it different names actually. Virtual work method. I like to call it power method. Unofficial name, I just kept it. Having a name is important. When someone says power method, immediately it registers, oh, we have to use that logic. So it helps to have a name. So what is the idea here? The main idea about this method is we're actually using energy. Now, ideal strings, they do not waste any energy and do not have any mass, so they don't carry energy. So ideal strings simply transfer energy from one point to another point. Means they take energy from one system, they give it to another system. They do not consume energy, or they do not waste energy. That means the total energy supplied by a string or total work done by tension is 0. Since strings don't take any energy. A simple idea, half mv square, mass of the string is 0, so half mv square is 0. So therefore, if total energy is 0, therefore total power due to tension is also 0. It is simply like you're taking energy from one place to another, so the person who's taking doesn't get anything there. And we know power cut definition is simply rate of change of work by time. Now, don't worry too much about this. This we will do in more detail in work per energy chapter. For now, I just wanted to get the idea there. So work done is force into displacement. Displacement of time is velocity. So there. So this is a formula I want you to know. Power. Power is given by force dot product velocity. This is the first thing that we need. Did you guys study something like that? Power is force into velocity.
Yes.
But you have an idea, right? So we have seen this in dot product. Me also I told you this. Fv cos theta, Fs cos theta. Simple ऐसे सोचो ना, power is nothing but work by time. Work is force into displacement. Displacement by time is velocity. So this is the first thing that you need to know. Clear? Second thing. Any doubts on this page? Next thing, tension. Now we'll talk a bit about tension also. What is tension exactly? So whenever you take a block or anything, hang it, the strings, right, always pull. So if you have a block hanging, if you look at this thing, tension T, so here T is the tension force due to strings. So this is important. Strings always pull. Meaning in this scenario, if you look at this, the same tension is pulling the ceiling down. If you look at the ceiling, the tension pulls the ceiling down, tension pulls the block up. So simply strings always pull. Think of like this: if you're hanging onto a, what do you call it, a pull-ups or something, pull-up bar, or if you're just hanging onto a ceiling, you're pulling the ceiling down, ceiling is pulling you up. Strings always pull. That is the main idea. What happens if you try to push? For example, let's say if you have a string like this, and let's say we have a person here who is pulling the string. So if you pull the string, the tension will pull him back. You can take your phone ka cable charger and you can see if you pull it, the charger will come towards you. But what happens if you push the cable? Same thing, if you take that thing and if the man tries to push, the moment you try to push, the string becomes loose. The word is slack. They say sometimes the string has become slack. That means there is no tension. You can try this a phone ka cable and see. You try to pull it, it will come. You try to push it, it just becomes loose. Isn't it? फिर भी your cable is still thoda rigid. It's like a wire. If you take thread now, you can clearly see. You can pull the thread, but you can't push the thread. The moment you try to push, it just becomes loose. Clear? So the main idea is strings always pull. This is the second idea in this thing. So method to me, you need to know a few things. One, power is F bar dot V bar. Second thing, strings always pull. Any doubts on this page? Clear? Next thing. We need a third ingredient, finding relation between tensions. Now see, all these ideas of learning, they will keep coming multiple times at different places. Suppose every time you won't be so lucky to get a single string. Sometimes you'll have multiple strings to handle. For example, like this. Now look at here. If you look at this entire green one is one string. This red one is a second string. So there are two different strings here. So now if I call this T1, if I call this pulley 1 and pulley 2, if I just draw pulley 2, you will notice, like I said, strings always pull. Getting it? So the red one is pulling it up. The green ones are pulling it down. You're getting it? So the block is being pulled up, the pulley is being pulled down. So the string is pulling both of them. I hope everyone is getting the meaning of pulling, right? Now you can clearly see here, since the pulleys are massless, so T1 should be 2 times T2. Agreed? Two tensions are balancing one tension. We are studying massless pulleys. If nothing is mentioned, we'll always take massless pulleys. So this is the basic idea, the relation between tensions. Now, if I give you one more example, keep it simple. Let's say this is B. Now you can clearly see this entire thing is one string. This is a second string. Make sense? So now if I draw that pulley here, the green ones are pulling up T1, T1, T1. Agreed? Three strings are pulling up. And this is T2. So here T2 will be 3 times T1. Is this making sense, everyone? So three strings are balancing one string there. So there are three people pulling here. There. So this is how you can find tension in the between two different strings. If the entire string is same, you'll have same tension. But if the string changes, you need to get the tensions also.
And here we don't consider the tension of the string held by mass A.
ये पुली में A
Achha,
कहाँ से आएगा?
if we talk
ना?
about the overall system, we'll have to include that.
ओवरऑल सिस्टम तो देन ये दोनों भी आएगा ना ऊपर सीलिंग का.
हाँ, okay, sir.
टच नहीं करते ओवरऑल सिस्टम का, देन अननेसेसरी विल ब्रिंग मोर, देन अर्थ विल कम इनटू पिक्चर. All clear with this? This is the third thing you should know. Now let's combine all three for this thing. Can I turn the page? Clear with this? Any doubts? Anyone not convinced? Please ask. Things should be clear, Ray. I know these are not tough, but kabhi kabhi you'll feel like something is goofed up. Maybe right now you might feel like everything is fine. After going home and after you're at home only, after seeing later on, when you see the notes, you will feel like yeah, something is goofed up. That is totally fine. Understand this. Not only my class, any class. When you learn something, if you register 70 to 80%, you're doing fine. There will be always the 10-15% confusion hoga. When you revise the notes, most of the time it gets sorted out. Sometimes still it keeps poking you. Please, ask the teacher, get it clear. You can ask me, no worries. Get it clear. Clear? Never think like, in the class only I should get 100%. Doesn't happen. There'll be always some 10-15% error. That is acceptable. So go home, revise the notes. That's the reason I keep telling you. After the class gets over, same day or next day, revise the notes, get things cleared. Let's see how to solve. Method 2, steps to solve. Step 1, label the tensions in the strings and find relation between them. Let's say there are 5 strings, label the tensions T1, T3, T4, whatever. And find relation between them. If it's the same string, tension remains same. Second, find power on each block. What is the power? Due to tension. So we can say power will be T bar tension dot V bar. You can write this thing as TV cos theta. You can also write this thing as T cos theta into V, where T cos theta is component of tension along velocity. We will see. I'll show you examples so you get better idea. Third, total power is 0. Because strings cannot consume any energy, total power is 0. So the power will be P1 plus P2 plus so on. If there are n strings, total power is 0. What's the total power? T1 bar dot V1 bar, T2 bar dot V2 bar plus so on. Tn bar dot Vn bar is 0. So Tn is the tension on the nth block. So if there are n blocks and n strings, Vn is the velocity of the nth block. No, it looks a little complex and all. Let me show an example. The main idea here is find tension, find velocity, and get TV cos theta and just add all of them, you'll get 0. That's the main idea there. Look at the steps. Any doubts on any particular step here, please ask. Let's see. Example. Let's take the one which we just did in the before. Which one? That three things wala. This is a this example, no, which we did 2, 3 VC, right? Let's say this is going with 2 meter per second. This is going with 3 meter per second, and this is VC. Step 1, find the tensions in the string. This entire thing is the same string. So tension T, this would be tension T, this would be tension T, this would be tension T, same string. Step 2, find the power on each block. Power on A, T and A are in the same direction. So T into 2. Actually, TV cos theta, but theta is 0 here. Cos 0 here. So basically, angle between T and V is 0 here. T and VA is 0. So there is no need to write directly. You can say, like I said, component of tension into this. Power on B is 2T, velocity is down to -3. Power on C, I don't know, TVC. Total power, 0. PA, PB, PC. So this would be 2T minus 60 plus TVC is 0. So VC is equal to 4. Make sense? It looks still big because I'm writing all the steps. Exam, you won't do all this. Let me take one more example. This one which we did, B. This guy is going down with A. This is going with U. This is theta. Look at this thing. This is tension. This is tension. This is VB. Power on B, T, VB, cos theta. or you can say T cos theta into VB. Power on A is minus T into U. Total power 0. You'll get minus TU, TVB cos theta. Tension cancels. VB is U by cos theta. No differentiation, nothing, you'll get the answer. This method works pretty neat. Just need to find the tensions, multiply with velocities and done. Is this clear, everyone? Clear, Surya? Sit straight now, Surya. Go wash your face and come. Go wash your face and come. You're gone. Clear with this? So it looks good. You'll get the answers fast, but we have a drawbacks. There are some issues with this. Like I said, if something is really good, you'll always have a drawback. You'll get nothing for free. So first thing, method 2 gives incomplete answers. Now here you said power due to tension is 0. But if there are other forces which are responsible for power, you'll get incomplete answers. Meaning, if you're sure there are only strings, this thing works pretty well. But if there are other forces, like later on we will see normal reaction and stuff. If there are other forces, this method 3 will take care of it. Responsible for power transfer. This gives incomplete answers. Second, method 2 is valid for velocities. And you can use this for accelerations also. But there's a condition. Can be used for acceleration if angles between tension and velocities do not change. More about this we will see in the next class. You have some pretty good questions on this. So what it means is, so T1 bar dot V1 bar, T2 bar dot V2 bar, so on till Tn bar dot Vn bar is 0. If you differentiate this with respect to time, you will get T1 bar dot dV1 by dt, T2 dot dV2 by dt, so on Tn dot dVn by dt. This will become T1 dot acceleration. So you can use this formula even for accelerations also. But like I said, the angles and the tension should not change with time. But have an idea about this. More about this we will see as we go on. You will see this thing. But you should know there are some limitations to this. So simply right now, what is the method? This is the main thing you should know. But today we will just handle this part. Let's see some problems. That will make things much better. So there in method 2, primarily you need 3 things. Power is F bar dot V bar. Second thing, tension strings always pull. Third, the sum of T1 bar dot V1 bar, the total sum is 0. The total power is 0 basically. Any doubt so far? Please ask me.
Sir, the angles between tension and velocities do not change. What is the meaning of that statement?
यहाँ पे देखो, जब ये block move करेगा, when the block comes here, didn't the angle change?
Yes, sir.
वो था. That should not change.
Okay, sir.
So we will see the same question. We will see velocitically it is fine. Accelerations won't work. We'll see more detail next class. Don't worry for now. Let's not put everything in one go. Let's see this thing. This is B. So if B is going down with you, find VA. Now here, if you try to use method 1, you'll die. There are 4 different strings. Let's get them. Let's see. Let me show you one. Let's start with the tension anywhere, okay? Start from anywhere. Listen carefully. I'll show you from here. Let this be tension T. Now, if you see this entire thing is the same string, so this is also T. So if this is T and T, this should be 2T, right? 2 people are pulling it. If that is 2T, this is also 2T, mean this is 4T. If that is 4T and this is 4T, now basically you're getting it. String pulls both the sides. This guy would be 80. This will be 80. So you're done. So power on A will be 8T VA. Power on B, later on we'll stop writing this. T into minus U. The total power should be 0. So we get 8T VA minus TU is 0. VA is equal to U by 8. So my direction is right. I assumed upward. I got it right. Make sense? So every time you go up a pulley here, tension is doubling up. Ever been to this museum in that Nerul? क्या था वो science museum, no? Nerul, I think when I went long back, 10 years back, I guess. There is a one setup there, you know, there is a table kind of thing. You can sit there and there is a rope here. You can pull the rope and you automatically go up. So basically this is called a mechanical advantage, meaning you can apply tension T and you can generate 8 times your tension. Isn't it? Meaning if I put 10 kgs here, I can lift 80 kgs here. If you put one more pulley, I'll get 16 times. It's called mechanical advantage. Ever heard that term? So there's something like that. You can apply less force and get more force. What about the fourth one? Next one. Same idea. Let's start from here. Let this be tension T. It is the same string. So this is T. This is 2T. Then this is also 2T. This is 4T. This is also 4T. So on A, total there are 3 tensions, 4T plus 2T plus T. When I say tension on A, I'm talking about the total tension on A. This is T into minus U is 0. VA is equal to U by 7. Check. Are you getting this method? Straightforward, right? Maybe assume the rim line is the tension of the rope is always normally pulling. See, rope always pulls the. See, when you have a pulley like this and you have a string, see now, it is like this. The string pulls the block up, the string pulls the rope down, isn't it? It pulls both of them down. So to balance these two tensions, this guy has to pull up 2T, isn't it? That way, strings will pull both the things. For example, see, if you and I are playing tug of war with a rope, what is a rope doing to you? It is pulling you. What is a rope doing to me? It is pulling me. Rope always pulls. So you have two tensions like this facing each other. Clear? All got this? Let's see one more. You can see how good this method is, right? You get the answers pretty fast. No need to think too much. There we have. Ta-da. So we have a man here who is pulling the two ropes. So he's pulling this side with speed U, this side with speed U. In this process, this block at the bottom is going up. Find V. You're getting how is it? You're catching the ropes on both the sides and you're pulling it. So this bigger block at the bottom is rising. So if he's pulling both the ropes with speed U from both the sides, with what speed is the lower block lifting up? Let's get this. Drawing a diagram is a pain. Just try to solve. Why do you think I took a photograph? But still, if you're drawing a pulley, right, this is a technique you can use to draw a pulley. I have seen people get confused. See, this is how you draw a pulley. Go straight, then make a circle, and then come back. You get pulley is good. Some people, they say first draw the pulley, and then they try to keep the block. The block becomes like this. It becomes weird. So it is better like this. Continue like this. Anyway, that is just a thing. Let's get this answer. Did you guys realize there are two strings? That is the first thing. If you had not realized, there are two different strings here. If you look carefully now, this is a different string. On the right side, this guy is holding a different string. This person is holding two different strings. Meaning, if you say this side, the tension is T, this is T, this is T, this is T, 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 and T, and T, this guy will be 2T. Both the sides, the tension is different, everyone. So this side, the tension is 2T. The rope has changed. Do have a look at the rope change there. So there are two different strings on either side. So if you look at the power on the man, the tensions and velocities are opposite. So minus TU, minus 2TU, minus 3TU. The power on the block, there are 6 tensions here. 1, 2, 3, 4, 5, 6. No, you don't count this. 6. 6 tensions are pulling up. Now, some people will get a doubt. Why are we not taking these tensions? These things won't matter. First of all, they'll cancel. Second, velocity is upward, tension is horizontal. You should take tensions in the direction of velocity. So this is 6 times t into v. The total power is 0 minus 3tu plus 6tv. V is u by 2. Check. Yeah, right, Ritik, you're right. What about the middle portion? What middle portion? Which middle portion, Ojas? Bolo na, unmute and talk na.
The one that is connected to the rigid part on which the
So you are only saying a rigid part. Is this moving?
No.
So what is velocity then?
Okay. Okay. Got it. Yeah.
Yeah. Don't make the man fall, Ray. He will die. Because of people like you only. Even no matter how much he works hard, you still make him work more. Clear with this? All got this? Why is the power of a man negative? Vihan, logically socho na. If you're trying to pull, are you gaining energy or are you losing energy? Let me say like this. I give you 100 rupees. Did you gain or lose? You gained. If I took 100 rupees from you, you lost. So the tensions are pulling the man out, right? And he's pulling the velocity. Aisa socho. String is there. Just look at his hand. He's catching the hand which is there. The hand, the strings are pulling this way, but the hand is going this way, isn't it? The hand is going towards him. So you're writing the power at the tip of the string. Clear? Next one. All got this? It looks big and complex, right? But it is an easy one. You have to be careful. There are 2 strings. Most people don't realize that. They'll take T on both the sides and that you'll goof up. This is going with 2 meters per second. Find VB. This is an easy one. Just a small trap is there. Let's get this. We have an incline. A is sliding on the incline. B is attached with a pulley with 3 strings now. So be careful. Every time 2T nahi hoga. You have to be careful. Show you. Let's see. Did you fall into the trap? Let this tension be T. So this is T. This is T. This is T. Let's say VB is going down. You can assume anything. Science take care of it. Now tell me one thing. When you say power of A, what is this? T 2 cos 0. Theta is the angle between tension and velocity. It is not the angle of incline. That 60 degrees is a trap. You're getting it? So be careful with that. So when you say here that theta is the angle between tension and velocity, that 60 degrees is good for nothing. It does nothing. Between T bar and V bar. So in this scenario, if you see tension and VA both are parallel. T is parallel to VA bar. Theta is not the angle of incline. Be careful. There is a mistake some people do. If you have not done, then it is good. If you have done, be careful next time. That's the whole point of the class, right? I have to make sure you do all the mistakes in the class only. My chemistry teacher always used to say, I don't do so many mistakes in the class, there's nothing left to do in the final exam. 2 by 3 meters per second. I took the direction down. So understand one thing. If you got plus means whatever direction you have taken is right. If you got minus meaning whatever you have taken, uska opposite. Generally we take always up, but here I took down. So it is fine. Clear with this? Easy. So that's it. The question is not tough or anything, but that 60 degrees is a trap. People have to be careful. Next one. Next one. This is VA. This is theta 1. This is VB. This is theta 2. Find VA by VB. Let's see. Let this tension be T. Let this tension be T. Now, what I'll do for convenience, right? Sometimes the angles can be confusing. So let's divide this into components. So this is T sine theta 1. This is T cos theta 1. Because sometimes, you have multiple strings attached, so you'll get confused like what the hell is happening. So dividing into components will keep your life easy, like what angle and all that stuff. Tension is same anyway. Now this guy is going with VB and this guy is going with VA. So now you tell me, when you take the power, which tensions are responsible for velocities? Can the vertical component ever help for VA? So only the horizontal components or the components along the tension will matter. So power on A will be T cos theta 1 into VA. So horizontal component into velocity. Power on V will be tension is opposite. So minus T cos theta 2 into VB. Make sense? Keep it simple. Divide into components, keeps your life easy. The total power is 0. T cos theta 1 VA plus minus T cos theta 2 VB is equal to 0. VA by VB is cos theta 2 by cos theta 1. Clear, everyone? If you want to use power ka that t cos theta, na, remember what is the angle between two vectors? Tail to tail, isn't it? So angle is actually 180 minus theta 2. So cos 180 minus theta 2 is minus cos theta 2. So that's what I'm saying. Sometimes you get confused unnecessarily. So don't do that. Just divide into components. Your life will be easy. All clear with this? Let me show you a variation of this. We have a ring here. So here we have a ring. The velocity of the ring is 1 meter per second. This angle is 60 degrees and this guy is going with 2 meters per second. This angle is 30 degrees. VB, I don't know. So if you look at the ring here, the string is passing through the ring. It is not tied to it. Find VB. How do we do? Again, the idea is the same. See what we do now. Let's take tension T, tension T, tension T. So just divide tension into components. So if this is 60, this is also 60. This is also 30. So if you look at the ring, look at the tension components. This is 30, that is 60. So this component would be T cos 30. This component would be T cos 60. So the vertical components are useless and the speed of the ring is 1 meter per second. So for the total power for A, it is T cos 60 into 2. That would be T cos 30 minus sign because it is backward into VB. And for the ring, it will be T cos 30 minus T cos 60 into V ring, which is 1. Are you getting the use of these components? Sabhi, dekho na, when you take the ring, now isn't it confusing? What should you take for power TV cos theta? It gets confusing. So best thing, divide into components, that will make your life easy. T gets cancelled everywhere. This is 1. This is minus root 3 VB by 2. This is root 3 by 2 minus half. Yeah, numbers are not great. So root 3 VB by 2 will be root 3 by 2 plus half. So VB will be root 3 plus 1 by root 3. or 1 plus 1 by root 3 meters per second. Clear everyone?
सर
हाँ देवांश.
सर यहाँ पे रिंग को हॉट पे करते तो
What?
सर लाइक वी रिंग को हर एक में से माइनस कर दिया तो सेम आंसर आ रहा है.
आएगा, क्यों नहीं आएगा? You're doing in relative motion.
हाँ
You can do that also. But every time your life won't be so simple. What will you do if I keep like ring like this? There is one more ring here. अभी क्या करोगे? अब समझ जाओगे ना? You can't stop a ring. अभी ये ring भी जा रहे, तो then you'll go mad. This will still work. No, the method is not wrong, but this is a more general one. What Devansh is saying now, that's an alternate method we can do. Relative motion. Stop the ring. So if you stop the ring, it becomes like part A, isn't it? So this guy will go with then VA minus 1. This guy will go with VB minus 1. Tension will remain same. This is 30, this is 60. So it will be T cos 60 VA minus 1 minus T cos 30 VB minus 1. You will get a VB from here. That's what you're saying, no? Same idea.
yes,
If you
sir.
stop that ring, you're actually using relative motion. It works. Clear? Because think about it. Why will the speeds change? Because you're standing on different frame. If a bus is going with 50 kilometers per hour, if you're in your house or if you're in a train, why will the speed of the bus get affected because of you? But I hope both the methods are clear. Relative motion is fine, good, but yeah. This is a more general way of solving. If you put 2-3 rings, you'll get stuck with relative. This will still work. That's it. Meaning sometimes exam mein na, see, there was a reason, nothing wrong with it, but problem kya na, exam mein will it click? Nothing much. So always think like that. If there are 2-3 methods, which method will click in the exam, focus on that and make it fast. For me, always this method clicks. The moment I see strings and blocks, I'll put tension method and finish it off. I won't think too much about different methods. Clear with this? Great. So with that, we'll wrap up for that day. So when we meet on Thursday, we'll continue from here. We'll do more variations of method 2 and then we'll do method 3 also. So we'll finish our string constraints this week, and next week we'll do rigid body constraints, and then we'll start with FBDs also. So after Thursday, I'll send you a small sheet also on all these type of questions. So on Thursday. So by Thursday, you finish off resolving the paper and also that units and dimensions ka sheet. So any doubts on that, we can handle that on Thursday. Okay, so with that, we will wrap up.